we'll move on to B tree. So from B tree, we'll move on to B plus tree. So B tree is an M-way search tree with some rules. So in a B tree, every node must have m by 2 childrens, and a root node can have minimum 2 childrens. Again, in B tree, all the leaf nodes must be at the same level, and the creation of B tree is going to be from bottom up, right? So for example, consider an example. So create a B tree of degree 4. So m value is going to be 4. It has 4 childrens. So you have 3 key values. So let us start by inserting the keys, right? So let us start by inserting the keys at 10, 20, 40, right? So it can have at most only 3 keys, right? So what happens when 50 is inserted, right? So it can have, since the degree is going to be 4, it can have only 3 keys, right? So we are going to, once 50 keys inserted, we are going to break the keys, and one key has to go up, right? 40 represents the root node, and you have 10, 20 in the left hand side of the root node, and 50 key as the right hand side of the root node, right? Again, we'll keep on inserting keys into the B tree, right? 60, 70, right? So this can be fitted in the right hand side of the root node. So what happens when you are going to insert 80 key value into the right hand side? So at most you can have only 3 key values, right? So again, you are going to split the right hand side, and one key value has to go up. So you have 50, 60, 70, 80. So you are going to split the right hand side, and 70 will go up, right? So I hope you are able to follow this B tree. Could have studied already, right? Similarly, now we continuously will try to add more keys into the B tree, right? So now let us insert 30 and 35 keys into the B tree. So 30 can be inserted. You can have 3 keys in this MA search tree or in this B tree, right? So 30 can be inserted. So once you want to insert 35, you need to split the left hand side. 30 will go up, right? So here now the root node has 3 key values. Only 3 key values are permitted in the root node, and all the leaf nodes, they have either 2 keys or 1 keys, right? So this represents a B tree. Here the idea is that whenever the node is filled, right, here at most the number of keys that can be present in a node is going to be 3. Whenever the node is being filled, it is split, and you are going to send it up, right? So now you are going to insert after 30, you are going to insert 35, right? So once 35 is inserted, you need to break this leaf node 10, 20, 30, 35. This leaf node has to be broken, or it should be splitted, and one key node has to go up. So 30 goes up. So at most you can have only 3 keys in the root node, and the root node has 3 keys. So we are continuing to insert some more records. We are inserting 5. So once you record 5, the left hand side, whenever the key value is going to be less than the root node, you are going to insert in the left hand side. Again, now you have 3 key values, so you don't have any issues in this leaf node. So once you insert 15, right? So once you insert the key value 15, you cannot insert more than 3 key values in the leaf node. So you are going to split 15 has to go up, right? You are going to split 5, 10, 15, 20, and 15 has to go up. And the root node, already there are 3 keys. So the root node can also accommodate only 3 keys, right? So what should we do is that again the root node has to be splitted and it has to go up, right? So once 15 goes up, 15, 30, 40, 70 will be there. Then 40 has to go up. 40 will be the new root node. 40, 15, 30, 17, and so on, right? So this is the idea behind B tree, right? How to, whenever you need to construct a B tree, we'll be constructing a B tree in this format, right? So the B tree, it has 2 pointers, block pointer and record pointer will be present for every node. So this is used for implementing multi-level indexing, right? So as I said that the idea behind studying B tree or B plus tree in this course is that this idea can be used for implementing multi-level index, so that we'll be able to decrease the block access time, right? So the primary index will be present in the memory, the secondary index will be present in the secondary storage device, so that you'll be able to, so that even if the index size increases, you need not have the entire index file in the memory. So the first level of indexing is done in the memory, and the second level of indexing is done in the second level of indexing is done in the secondary storage device, right? So B tree has a child pointer and a record pointer. Right. So in the case of B plus tree, it's an extension of B tree, where we'll not have a record pointer for for every node. We'll have record pointer only for leaf nodes, right? So B tree is used to represent multi-level index, whereas B plus